Okay, now I'm going to work out this snowstorm question. So, question goes like this. Probability of a snowstorm on any December day is 0.25. So, probability of snowstorm, 0.25. If there's a snowstorm, there's a 70% chance your flight home is going to be delayed. So, probability of delay given snow is 0.7. If not, the chance you will depart on time is 95%. So the probability of delay given no snow, well, I said it's 0.95, or there's a 95% chance you're going to depart on time. So the probability that you have delay is just the complement of that, not on time. And that's 0.05. Okay, and so what's the probability, or this says what is the percent chance that you will get home on time? So we're going to assume that means no delay. Okay, so what events are dependent on what? Well, the delay is dependent on whether we have snow or not. So let's start with the snow. So probability tree starts out like this. So we've got snow. This happens with probability 0.25, no snow, 0.75. Remember, you have to have enough branches to account for all of the possible outcomes. Since it's snow or no snow, those are complements. We got it all. And they add up to 1, the probabilities here. Okay, so probability of having a delay with snow, this is 0.7, which means probability of no delay is going to be 0.3. Here, the probability of delay if without snow is 0.05. Probability there's no delay, we were given 0.95. Okay, so now we get to calculate the probabilities on each of these branches. So the probability that there is, actually before that we even do that, let's figure out which branches we care about, because that will cut down the arithmetic. Okay, the question is we want the percent chance that you will get home on time. So in which of these cases do you get home on time? Well, it's not that one, because that's a delay. It's not that one, because that's a delay. This one you get home on time, this one you get home on time. So you really only care about those 2 branches. So to get this probability, so now we're doing dependent events, but so we still multiply these together, okay? Because we're saying, all right, snow, 0.25, and then once you've given that you have snow, the probability of delay is 0.3, or of no delay is 0.3. So we're going to multiply those together, and 3 times 25 is what? 25. 75. So 0.075 is your probability here that you have snow and there's no delay. And the probability that you have no snow and no delay is going to be 0.75 times 0.95. So it's almost 0.75. So all you do is you calculate this, and then you add them together, and then that will give you your probability that you leave on time. So this is pretty close to 0.75. I'm just going to guesstimate it as 0.73, which I have to check the math on. And then I'm going to say, actually, let's make that 0.72. And then I'm going to add these guys together to get the total probability. So it's around 0.78. And so the percent chance that I will get home on time is going to be 78%. And then I'm going to common sense check that. I'm going to say, okay, does that seem feasible or plausible? Well, let's see. Okay, so there's a bigger chance of having no snow. And if I have no snow, there's almost no delay. If I have the smaller chance of having snow, then you're pretty much hosed. So yeah, so this is a little contribution, but you're going to have a pretty big number here for the percent chance of getting no snow and no delay. So I will buy that 78% makes sense.